Hi again, everyone. In this next video, we're going to look at solving equations containing decimals. So I gave you some steps that you could use when solving equations. So feel free to refer to those steps, when you're solving equations. But just remember, there's no one size fits all. All equations are different. And sometimes, you have to use different techniques, maybe in a different order, to isolate the variable. Okay, but what we're going to look at today is just how to solve an equation that has a decimal. So you have a couple options. You could leave the decimal the way it is and just solve the problem as is. So for instance, in letter A, this is a relatively easy one. Here you're trying to get x by itself and you want to move that negative 1.5. So you're going to add 1.5 to both sides. And when I add decimals, I need to make sure the decimal points are lined up, right? So 8 has an invisible decimal that we don't see. And then there's a bunch of zeros after it that we also don't see. When you add, you're just going to start on the right side. So 5 plus 0 is 5. You're going to line up your decimal. And then 8 plus 1 is 9, right? So that seems pretty easy. You get 9.5. And if you check it, you would just replace x with 9.5. 9.5 minus 1.5 is 8, okay? So that's method number one. Or you can try doing it like this. So you can get rid of decimals by multiplying by a power of 10. So how do I know which power of 10 to multiply? When I say power of 10, I mean like 10, 100, 1,000, 10,000. So what you do is you look at the number of decimal places to the right of the decimal. So in x, we've got a 1 here that we don't see. Okay, so we don't have to worry about that. Here we have 1.5. There's one place after the decimal. And in 8, we don't care about the 0. Remember, that wasn't even there. So all we have is one place after the decimal. So if I multiply by a 1 with 1 0, which would be 10, it will move the decimal away. You won't have any decimal points. The trick is you need to do that to everything though. So if I take my equation and rewrite it, okay, and this time I'm going to put the 1 in front of the x. Okay, I want you to see what's going on here. So if I multiply this equation by a power of 10, so if I multiply by 10, what's going to happen is it's going to move that decimal to the right one. But it does that for all of them. So you have to remember that this 10 is affecting everything in the equation because it's keeping it balanced. So we have to do 10 times 1, which would be 10, minus, okay, 1.5, if I move the decimal to the right one, I get 15. And then 8 times 10 is 80. And then you would just solve that as you normally would. So we're going to add 15. And the negative 15 and 15 cancel. And we get 10x equals 95. And then we're going to divide by 10. And 95 divided by 10 is 9.5. So you get the same answer. Okay, it's just another method, another way of solving it. So I'm going to use the new method, and this way we can practice that. If you want to solve equations normally without removing the decimal, that's okay too. Okay, so in my next problem, I have negative 2y equals 6.7. So again, I'm going to scan the equation and I see one place after the decimal. So if there's only one place after the decimal, I'm just going to multiply by 10, okay, so because it has 1 0 in it. If there were two places after the decimal, like say this said 6.73, you would multiply by 100, okay, because it has 2 zeros. So now you're going to multiply everything by 10. So negative 2 times 10, that's going to give you negative 20y. And 6.7 times 10, remember, just moves the decimal to the right one. So that would be 67. And then now you would just solve it like you would normally. So we want to get y by itself. We're multiplying by negative 20, so we want to do the inverse, which is divide. So we're dividing 67 by negative 20. Okay, and feel free to use a calculator. So an app that's really easy to use and does everything and is free is called Desmos, Desmos. So here we had 67 divided by 20. It comes out to 3.35. And it's a positive divided by a negative, so our answer will be negative. So it's negative 3.35. Okay, in my next problem, I'm going to scan the problem. I see decimals, but I only see one place after each decimal. So that means I'm just going to multiply the equation by a power of 10. So all that's going to happen is the decimal points are going to move over one place. So you're just going to end up with 12x plus 58 equals 82. And then you would solve this like you normally would. So to get x by itself, I'm going to subtract 58. 58 minus 58 goes away. Then we have 82 minus 58. So that gives me 24. And then I'm going to divide by 12. And 24 divided by 12 is 2. In my next problem, I have, again, one place at most after the decimal. So I'm going to multiply by what? You guessed it, 10, because it's got 1 0 in it. So now I just need to multiply everything by 10, okay, all the terms. So remember, 10 times 7, it's going to give me 70. So it's the equivalent of just moving the decimal after the 7 over 1. So you get 70x plus 32 equals 10 times 4, 40x, and then minus 16. Okay, now I have an x on each side. So remember, when that happens, I can't just combine them because of that equal sign. It's preventing me from doing that. So I have to move the x's on the same side. So you have a couple options. I'm going to move the 40x with the 70x. So to do that, I'm going to subtract 40x. And the reason I'm subtracting is because it's a positive 40x. So we always do the opposite. And 70 minus 40 is 30x. Everything else you just bring down. Okay, remember the 40x and the negative 40x go away. Okay, now I need to move this number, 32, over with the other number, because I can't just combine them unless they're on the same side. So to do that, I'm going to subtract 32 from both sides. Okay, and again, the reason is because I was adding, so we do the opposite. And 32 minus 32 cancels, and you get 30x equals negative 16 minus 32. So we're adding, right? Adding two negatives, that's a negative. You just add them and keep the sign. So 2 plus 6 is 8, 1 plus 3 is 4. So it comes out to negative 48. And remember, you're not finished because it's 30x, and we need to get rid of that 30. So we're going to do the inverse. We're multiplying 30 times x. So the inverse of multiplying is dividing. So you get x equals, you could write your answer as negative 48 over 30, and then just reduce that if you wanted. So they're both even numbers. You could try 2, but I also know that 3 goes into it. So I'm going to divide by 3. And negative 48 divided by 3 is negative 16, and 30 divided by 3 is 10. Okay, so since I have two even numbers, that means that I could simplify it again. So if they're even, just keep dividing by 2 until you can't divide anymore. And then it's completely simplified. So negative 16 divided by 2 gives us negative 8, and 10 divided by 2 is 5. So your final answer would be negative 8/5. If you wanted to write that as a decimal, you could just, again, to change a fraction to a decimal, just divide. So we're going to divide negative 8 divided by 5, and it comes out to negative 1.6. So that would be acceptable to write your answer like that too. So you could either put x equals negative 8/5 or x equals negative 1.6. Okay, for my last example, letter E, notice you have 5 and then you have times the quantity x minus 0.36 equals negative x plus 2.4. So in order to get to this x, I need to first distribute 5. So I'm going to do 5 times x and then 5 times negative 0.36. So here I have 5x minus, okay, and then we want to figure out what's 0.36 times 5. So we get 1.8. And it should be negative because you have a positive 5 and a negative 0.36. Positive times negative is negative. And I'm just going to carry everything else down. Okay, so this is very similar to the last problem, except we have we have decimals there. So we want to get rid of the decimals and then we want to move things around. So again, if you look, the most number of places I have after the decimal is 1 spot. So that just means I can multiply by a power of 10, and that will get rid of the decimals. So 10 times 5x gives me 50x. 10 times negative 1.8 is just negative 18 now. 10 times negative 1 gives me negative 10x. And 10 times 2.4, remember, just moves the decimal over 1 spot. So it's going to make it 24. Okay. Now I want to get x on one side just like I did in D. So what I'm going to do is move this negative 10x over with the 50x. So to do that, I'm going to add 10x to both sides. 50x plus 10x is 60x. And I'm going to bring everything else down. Negative 18 and 24. Negative 10x and 10x are opposites, so they're just going to go away. Now I need to move this negative 18 over with the 24. Okay, again, I'm trying to isolate x. You're trying to get x by itself. So now I'm going to add 18 to both sides. So you get 60x equals 24 plus 18, which is 42. Okay, and I'm going to move this up here. Okay, x is still not by itself. I need to remove the 60. So to do that, I'm going to divide, because you were multiplying 60 times x, so you do the inverse. And now we get 42 over 60. Okay, and that is not reduced. You can reduce that. I know 6 goes into 60, and 6 also goes into 42. So I'm going to try dividing the numerator and the denominator by 6 to reduce it. 42 divided by 6 is 7. And 60 divided by 6 is 10. So your final answer is 7/10. Okay, and you can leave your answer as a fraction. Again, if you want to write it as a decimal, to change a fraction into a decimal, you just divide. So you would just divide 7 divided by 10, which is 0.7. And then the rest of the problems are for you to practice. So you can try practicing 5 more problems. Again, you can solve these without, doing anything to the decimal if you want, but some people prefer to remove them to make it easier. Okay. If anybody has any questions, please feel free to reach out to me. Please make sure you're taking the time to practice this and also to complete your homework on MyLab. Have a great day, everyone.